When we talk about memory, we are referring, by the very definition of the term, to the recollections of events that lie in our past. That is, we are talking about time. Without time, there would be no memory. Before we speak to other people, we formulate thoughts that become organized and transformed into forms of verbal communication. To maintain a dialogue, we constantly consult the archives of our memory. This process takes time. In short, one could say that only that which can be remembered truly exists. For example, there are dark regions in the night sky where numerous stars exist and whose light of fixed and limited speed has not yet reached us. Although they do not exist for us, because they are not remembered, the stars will still be there. This detail draws attention to the limitations of our subjective and secondary evaluation, structured on the five senses, since the primary universe does not depend on what we think about it. Reading some works on physics, my attention was drawn to a process that occurs at the subatomic level of matter, called quantization. It discusses the nature of light, which presents itself to us in the form of small and isolated packets of energy, which we know as photons. All forms of energy that we can detect and measure are quantized. To be perceived by our senses, and even to be captured by our best tracking devices, light needs to be packaged. It has already been experimentally proven that this process of quantizing light does not require time. The quantum is delivered to us, ready-made, as if it were already part of nature. The experiment that demonstrated this fact consisted of promoting a collision between a unit of energy, a quantum, and a free electron on a metal plate. According to the prediction of classical physics, when the quantum collided with the plate, the electron should absorb energy until it could perform its quantum leap. For this, it would need some time interval, however minimal. In 1925, Bose and Geiger demonstrated that at the exact moment of the collision, the electron and the scattered quantum appear simultaneously, without any time interval separating them. The timelessness of the quantization phase should not be disregarded, as it would introduce discontinuity to the functioning of our memory. Being time-dependent, our memory could not register what happened to the electron until the exact moment of its quantum leap and the scattering of light. Therefore, quantization predicts an information gap, whether apparent or not, which would explain why an electron cannot be found in the space between two subsequent energy levels of the atom. This gap, which does not necessarily imply the absence of information, but rather the impossibility of it being directly recorded, is related to Heisenberg's uncertainty principle. According to Martin Eisbert, another physicist, the uncertainty principle is a direct result of the quantization of energy. Fundamentals of Modern Physics, page 141. Basically, the uncertainty principle implies that subatomic particles can never be seen in real time. What we see are their images, displaced in time and space. To be seen, real particles must first be illuminated. Their illumination disturbs the particle in an unavoidable way. It is often said that we are always chasing after them without ever reaching them directly. When we see the particles here, they will already be in another place in space and at another moment in time. Even so, after being illuminated, subatomic particles leave a trace, which allows us to follow them through time. There is an interesting aspect to be addressed when referring to the subatomic level. The microscopic world is usually analyzed in a way that is dissociated from what happens in the macrostructure of the universe. For example, in physics, one could not compare the orbit of an electron with that of a planet. When the two levels mentioned are confronted, the laws of gravity seem to clash. It is as if there were two distinct universes, virtually separated from each other. Unless I'm mistaken, the only way to unify them would necessarily involve the observer and the phased way in which he registers the events that occur around him. That is, to observe a subatomic particle, there needs to be local scattering of some type of light or radiation. The same occurs when it comes to observing a distant star. If its light were no longer present at our observation point, the star could not be seen, which would lead us to conclude that it does not exist. Local scattering would eliminate all the time that starlight would have previously spent traveling through space, since we cannot directly assess that time. The speed of light, measured in the past, would become a form of sensory illusion, as it was already with us when a star was sighted. Without the constant presence of light from any star, our telescopes would be useless. I mean that the basis for the unification of all levels of matter would reside in the same way in which they are observed. Note that this goes against the concept of memory, which we usually develop in relation to external events. We see stars instantaneously because we remember them without depending on the previous displacement of their light in space. Newton predicted that gravity would act between bodies at a distance and instantaneously, which has become a matter of great controversy today. If nothing can move faster than light, how could information about gravity do so? Although Newton did not attempt to explain how the instantaneous action of gravity would occur, the answer may lie in a great scientist's memory. This is because the previous displacement of starlight and the time required for it does not exist for us, because it cannot be remembered. The observer, even registering everything around him with a delay, has the impression that he does so instantaneously. Therefore, he seems to carry with him a zero mark of time, without depending on the physical position he might occupy in space. Being in the vicinity of Jupiter, he would have the sensation that he would continue in the present, and that everything around him would be seen with the appearance it had in the past. The detail seems to place the observer virtually at the center of an information bubble. We believe we are in the present because we see everything around us in an apparently instantaneous way, even in the face of the undeniable evidence that reality would be presenting itself to us with the appearance it had in the past. It is clear that this data would have to have some relation to the timelessness of the quantization phase. Both the formation of our memory and the quantization of energy would be timeless processes, inseparable from each other. By being in touch with the memory, the observer seems to have been prevented from interacting in real time with the universe throughout his short existence. It is as if his memory had created a copy, a mirrored image of reality, that would allow him to walk through environments without stumbling over obstacles. Another interesting aspect of memory refers to the concepts of future and past. If the observer carried with him a zero mark of time, even without fully understanding what that means, he would conclude that the past would be a kind of illusion created by the necessary timeless quantization of light. It would force him to keep groping matter as if he were touching it in real time. Furthermore, when we observed everything around us with a delay, the present and the future would become the same thing. The future would be the result of looking at the present moment of the universe as if we were in the past. This would be an illusory sensation, but it tells us that the observer would have been forced to go back in time. Only in this way would his interaction with the universe to which he belongs becomes possible. Each dive into the archives of memory would create a false dichotomy between our mind and our physical body. Since the observer's memory is part of his brain, one could say that his physical body would be in the present, while his consciousness would be traveling through the past of the universe in a curious form of temporal exile.